Hello everyone, welcome to the control system. This is part 9 of lecture 6 on state space representations. In this section, we'll discuss the transformation from state space to transfer function. And we already discussed how to transform from transfer function to state space in the previous video. So let's consider the system whose transfer function is given like this. Okay, it's a general one. So this system may be represented in state space by the following equation, these equations, okay? And we want to find the relationship between this time domain and this frequency domain. So in order to transform from time domain to S domain, you need to do Laplace transform, assume initial condition equal to 0. If you want to transform from S domain to time domain, you need to do inverse Laplace transform. Assume zero initial condition. Okay. So if you do the Laplace transform of this equation, you will obtain this one. Well, in this section, I'm not gonna tell you how to do Laplace transform or inverse Laplace transform. Okay, because we have one whole lecture on Laplace transform in lecture 2, and I assume that you already know how to do Laplace transform by yourself. And then, okay, by rearrange the first term, this is 0, right? 0 initial condition, and move this term to the left hand side, you obtain these equations, okay? And this is equivalent to this one. And then by multiplying this Si minus A inverse to both sides from the left hand side, you will obtain Xs equal Si minus A inverse Bus. And then substitute this equation into the output equation, equation 9. You will obtain this equation. And Laplace transform is transfer function is a ratio between the output and the input. So Ys over Us equal this one. So this is Gs, all right? So one, you know A, B, C, D, and then you can find Gs in S domain. So let's find the transfer function of this form. So in this case, D is 0. You can spend 5 minutes on this, only the 2 by 2 matrix, so it is not so difficult for you. After you find a solution, you can come back to the class. So I give you the answer to check. Okay. All right. So you can also obtain the transfer function from the state space equations in MATLAB. Use the following commands. Okay, MATLAB make life a lot easier. You need to specify the numerator, denominator, and using this command, A, B, C, D, and then IU. So IU must be specified for the system with more than one input. For example, if the system has 3 input, you want you to use 3, then IU must be either 1, 2, or 3. Okay. And if the system have only one input, then you can either use this one. You don't need to specify IU. Okay, so let's consider this state space equations. Okay, so how can you obtain the transfer function using MATLAB? Okay, and we can do a little bit of demo. MATLAB, so I need to clear. This is my practice, so we need to specify A. So what is the matrix A? 0, 1, 0, and 0, 0, 1. Minus 5. This is not correct. Okay, I need to. So A again equal 0, 1, 0, comma, and then you can type directly 0, 0, 1. Okay. So this means this comma means this is in the second row. Set row minus 5, minus 25, and minus 5 again. Okay. This matrix A and matrix B is a 3 by 2 matrix. 0, 25, and 120. And then C equal 1, 0, 0. D equal just 0. And now you can transform. You can find numerator, denominator of the transfer function by using SS2TF and specify A, B, C, and D. See, this is a transfer function. Print to check new, and see, this is the answer. This is the transfer function you obtain using MATLAB. Okay, let's get back to the class. The slide, not the class. Okay, so this is how you transform from state space to Laplace, from Laplace to trace state space. Okay, so if you have this state space form in time domain, you can use this functions. It's also fine, just SS A, B, C, D, and it will output the state space object. Okay, and you can also use this as well. This is the transfer function, and then you use this SS command, so you will have this object. And yeah, if TF from this one to this one, so it create an object. Okay, for example, obtain the state space representation of this transfer functions. How can you do it? This, okay, state space representation, it means which one of these. You can do what I did before, is also fine, but if you want to create the object of this, you can use which one? This one. Okay, so but you need to create the object first. Okay, next one. Yeah, this is another comment for you to calculate the output, respond to the state. Okay, LSIM, input the system. This is a system. You need to input the U is an input. T is the time, and X0 is the initial conditions. Okay, and this is the code to if you wanna use LSIM. Okay, this is the end of the lecture 6. Thank you very much.